Hello guys, I welcome back to my channel CSNet Lectures. So in this session we are going to discuss about the two algorithms which we are using infrequent in circular cube. So before going into this algorithm, I request you all to watch all the previous videos of how the manual operation is done for the circular cube. Suppose if you have a clear idea only, you will be able to follow this algorithm, right? And I also tell you that you must have to see the formulas which I have mentioned in the last video. So formula for full, how to insert, how to delete the elements, what is the condition for empty. So all those important formulas I have told. So please watch it and then come over here, because we are using those conditions, that is we are using those formulas to implement this algorithm. Okay, so now shall we move on to the topic discussion? Right. So in this video we are going to discuss about NQ algorithm. Then in the next video we are going to discuss about DQ algorithm. Right. And simultaneously we are going to see its time complexity for executing this algorithm. Right friends. So friends, I request you all to watch my videos, like and share and subscribe, so that it will be a great motivation for our team. Right. So this is the diagrammatic representation of a circular cube. So a circular cube will be represented in this manner, right? And based on this representation, we are going to see how the actual structure of the circular cube will be present internally, right? So both we are going to draw for having a easy discussion for you. Okay friends, so shall we proceed? Right. So now this is the algorithm. Okay. So we have used three conditions for inserting the elements, right? So what is the first condition? We must have to check whether the queue is empty. Suppose if the queue is empty, we are directly entering the element by positioning the front and rear pointer to the 0th location, right? Suppose if the queue is full, is it possible for us to enter the elements? No, it is not possible. So we are printing that it is full, right? Then we are using the last third condition in order to increment the rear pointer. So see, this is the formula. So rear is equal to rear plus 1 modulo max. So this is a very important formula. Suppose if this formula is not being given for us, what we will be doing? For each and every operation, we must have to write the condition. Okay, there are many conditions. So what are all the conditions? I have told it already. That is, we will be discussing whether front is not equal to 0, or we will be saying whether rear is equal to n, or front is equal to 0, or rear is not equal to 0, or we must have to reinitialize the rear pointer back to the front location. Okay, so it is a very big process. So in order to avoid those condition checking, we are using the formula directly, right? So while coming to this point, I will tell you what is the condition which I have written it in the last video. Okay friends, so now we are going to start inserting the elements. Okay friends, please follow. Suppose if you have any doubt in my teaching area, you just mention it in the comment section. So I am there for explaining it to you again, right? Friends, this is a circular queue representation. So initially when you just see the queue is empty, that is the circular queue is empty. So now in this empty circular queue, we are going to start inserting the elements, right? So now friends, another thing you must have to make a note of it is what are all the variables that I have used in this algorithm. So we will just have a quick review of this. So what are all the variables used? I, N, F, R, max. So I is used for using it in the for loop, and N is going to tell what is the maximum number of elements that I am going to store in my queue. Then F is denoting front pointer, and R is rear pointer, and max tells you what is the maximum size of my circular queue, right? In the circular queue, I am going to insert characters, right? So what is the data type of that character data? So it is CHAR, so character data type. So the name of that data is alphabet, so alpha. Okay, so what is the maximum size? I am going to create 5 characters inside my circular queue. So here we are using the representation of arrays for storing the elements. We can also use linked list for storing the elements. Since array seems to be very easy for understanding, I have took up this area, right? So these are all the different variables which we are going to use it in my algorithm, right? Friends, are you all clear what all the variables that is being used? Okay. So now we are going to draw the circular queue, that is we are going to insert the elements inside the circular queue by taking each and every element into consideration, that is each and every statement into consideration. So now I am going to start from here. So what is the reason for using this for loop is, it is used for inserting each and every element, that is we will be picking up one element from the user, that is I am going to insert one element, right? I will be giving the element. So after giving one element, we are going to perform these conditions. Okay, suppose if any one of the condition is satisfied, n will be inserted, right? So for each and every element that the user is giving, for that I am used this for loop, right? So for loop is used for operating on single element what the user is entering. Okay, so this you can leave. So we can go for discussion for if conditions. So now initially Q is empty, isn't it? So take the first statement. If F is equal to R is equal to minus 1. So what is this statement tells? F equal to R equal to minus 1. So what is this minus 1 tells? So I have told if front and rear pointers are equal to minus 1, the meaning is the pointers are outside the circular queue. That is, still we have not brought that pointers because there are no elements, isn't it? So when you see this diagram, right? So when you see this diagram, so you see, can you be able to see whether front and rear pointer is present? No, because there are no elements. So it is outside of the data structure. So this condition is true, isn't it? So this condition is true now. So what I must have to do? I must have to insert the first element inside the data structure. Okay, so what I should do? I must have to bring inside the pointers to point to the first location. See, like this. So this is my first position. So what is front pointer and rear pointer? So front is equal to rear is equal to 0. Like this we must have to bring the pointers first. After we are making the pointers to point in, we are inserting the elements. So this statement is used for inserting the elements then. So alphabet of R is equal to item. So what is this item? So item is the character what the user is entering in the screen. So here I have left out, so item. So this is also a character data type. So X is the first element that the user has entered. So since this condition is satisfied, we are placing the pointers in the 0th position. Simultaneously I will write it here also, friends, because you can be able to follow. Okay, so now what is the element that is being inserted? That is X. It is a character value. So let me insert. So X. Like this it will be inserted, right? So now what we are going to do? So once again another element is coming, right? For example, I want to enter another one element Y. Okay, so once again what we are going to do? We are going to start checking from the first. If F is equal to R equal to minus 1. So now see the circular queue data structure. Is this condition is satisfied? No, because now at current F and R is equal to 0. Isn't it? So this condition is false. So now we are going to skip this block of statements and we are going to come over here. So now check this condition. If F is equal to 0 and R is equal to n minus 1. So what is F value? So F value is equal to 0. So this is true. What is another condition that is being given? R is equal to n minus 1. Okay, so n and max is used for telling what is the maximum size of the element present in the circular queue. So friends, here n and max value we are fixing it as the maximum size as 5. We can directly use this n variable alone for n minus 1 and for max, or max alone for all the variables. For better understanding, let me use one variable alone, right? So n is equal to 5. You didn't want to have a confusion. So we can delete this max variable. So here also I can use as n. All are having the same meaning, okay? We can use the same variable for all this algorithm operation. Okay friends, are you all clear? Okay. Now, if f is equal to 0 and r equal to n minus 1. So now tell me, suppose if the maximum size of the element is 5. Okay. So 5 minus 1 is equal to 4. Okay. Now tell me whether this condition is satisfied. So f is equal to 0. Right. So now r is equal to n minus 1. So what is n minus 1? So n minus 1 is 4. Since this is 4, now you tell me in the structure whether r value is pointing to the fourth location. No, it is not pointing to the fourth location, isn't it? So now what we are going to do? This condition is false. So we are going to skip this condition also, right? So now both the conditions are false. Now automatically this else statement is going to get executed. So this is the formula for incrementing the real pointer to one location, that is real equal to real plus 1 modulo size. Okay, so this formula you please remember. So it is used for incrementing the real pointer to one location. So what is real value? So the real value is 0. So 0 plus 1 modulo n. So n stands for 5, isn't it? So 1 divided by 5, that is, what is the modulo value? It is going to give you the remainder. So 0, 1 modulo 5, you will be getting the answer as 1, because it is going to give the answer as for the smallest value. So 1 is the answer. Now real value is going to get incremented to n, will be incremented to first location. So this is your real value. So here also it is going to get incremented. Okay friends, so can you follow? So now we are going to insert this y here and here. I am going to insert the element. Okay, in circular, that is in the normal Q data structure, what we will be doing, each and every time we will be inserting the element and we will be incrementing the real pointer. But here we are using this one for incrementing the real pointer in order to see what will happen if there is a chance for making reinitialization to 0. For all those things, we are combined together as a one formula. Okay friends, are you all clear? Now we have inserted the element, that is alpha of r is equal to item. So item is equal to y. Similarly, we are going to insert the elements for all the remaining locations, right? So now, shall we start insert? Right. So now another element is coming. Okay, another element is coming. For example, is I want to insert this. Similarly, we are going to check all the conditions. So now what is the value of f? F is equal to 0 and r is equal to 1. See, f is equal to 0 and r is equal to 1. Okay, so this condition will also be failed, isn't it? So this also will be failed because r is not equal to 4. Here r is equal to 1. So once again we are incrementing the real pointer. So now r value will be 1. Isn't it? So 1 plus 1 divided by n. So you will be getting the answer as 2. So in this second location, we are inserting the z value, right? So real pointer will be moved here and we are inserting the element as what? Z. So here I will insert as z. So similarly, we are going to insert in this location. So now again, if you see, this condition is false, isn't it? Because there are elements present. So still r has not reached n minus 1. That is not, it has not reached r is equal to 4. So this condition is also failed. So again this is going to get executed. So what is r value? So r value is 2. 2 plus 1 is 3. So in the third location, any other element, for example w. So w is going to get inserted. So increment the r value here. What is the element came? W. So here also I am incrementing. So you are getting the value as w. Friends, are you all clear? So now similarly do the same checking operation for next element. For example, p is the next element, right? So this will be failed, isn't it? So since f is r, f value and r value is not equal to -1. So it is false. So here if you see, f is equal to 0 and r is equal to 3. But here what will be the answer? If r is equal to 4 only, it is telling that it is full. So this condition is also false. So now once again we are going to execute this for else part. So what is r value? So r value is 3. So 3 plus 1 is 4. So alpha of 4 is equal to item. So what is item? I have entered. So it is p. So store that value as p by incrementing the rear pointer using that formula, right? So here I am incrementing and I am printing the value as p, inserting the value as p. So now for a case we are going to do some deletion operation, and finally we are having certain elements in the circular cube. So what are those elements? For example, this x and y will be deleted. Okay, so this f and y will be deleted and front will be pointing here. So here where it is x and y I am deleting, right, and it is pointing to z. Now we will see manually, if you see where the next element has to be inserted. So it has to be inserted here in this 0th location. Okay, so now we will see how it is getting inserted. So now what is the value of front? So front value is 2. Okay, so the front value is 2 and rear value is 4. So now is this condition satisfied for the value? No, it is not satisfied. So come here. So f is equal to 0 and r equal to n minus 1. Okay, what is f value here? So f value here is 2. So this is false and this is true. If both the conditions are true, only this value what I have said will be printed. Okay, so once again you see this else part will be executed. So clearly watch now friends. So now what is r value? R value is 4. See, r value is 4, right? So 4 plus 1 is 5. So 5 modulo 5. What will be the answer? You will be getting the answer as 0. Can you follow how I am substituting the value based on the front and rear values? Right. So now alphabet of r. What is r? R is 0. So now based on this formula, this rear pointer is getting reinitialized to 0. Okay, now rear is pointing to this location. Now we are inserting the element. So let the element be, yes. So what we are making? We are incrementing this rear pointer here. And I am storing the value as yes. Okay friends, this is the efficiency of using this formula. Instead of using the conditions checking again and again, we can use this formula directly for inserting or incrementing the rear pointer. You will not have any problem in moving the rear pointer. It will be moving circularly without having any disturbance. Okay. So friends, I think you will be clear now what is efficiency of using this formula. What is the advantage of using this formula. So keep in mind, for incrementing the rear pointer in circular queue in any directions, what is the formula? Rear plus 1 modulo size. This is the thing or the point which I must have to tell to you. So please remember this, right? So this is the way we are implementing the circular queue algorithm. Right friends, I think you will be having a clear idea about this, right? So now we are going to see the time complexity of executing this algorithm. So whenever we just use this algorithm, we are using the front and rear pointers, isn't it? So here we are, whatever the cases, whatever the conditions are present, we are incrementing the rear pointer to only one location. We are directly inserting the elements rather than making the rear pointer to traverse all the directions, right? So for example, so friends, in this diagram if you see, if I want to insert in this blank area, I am just going to increment the rear pointer to just only one location. That is only one move I am making. isn't it? So I'm making only one move. So the time complexity is just for 1 second. Okay, or 1 second or 1 millisecond or 1 microsecond, no problem. So the time complexity of moving or inserting the element in a circular cube is only used by only one move. So the time complexity is what? So we can tell as it is O of 1. It is a very important point, so please make a note of it. Since we are directly depending on the rear movement. Okay, so rear movement is only one move. So we can tell that the time complexity of circular cube is O of 1. Okay friends, so I think so now you would have a clear understanding of all these points. So please make a note of it friends. In the next video we are going to discuss about DQ, that is deletion operations in circular cube. Bye.